Hello and welcome back to Friday 15. So today, our topic today is Class 4 power systems. Also, you may have heard it as Fault Managed Power System, or FMPS. So with me in the studio is Rodger Hyle from a company called VoltServer. He'll be telling us a bit about it, but mainly VoltServer is the pioneer of a form of FMPS called digital electricity. So today you're going to be hearing in the next 15 minutes kind of interchangeably us using the terms FMPS, fault managed power systems, class 4 power, digital electricity, but they more or less mean the same thing. So that's a little intro. But before we begin, Rodger, tell us a little bit about VoltServer. We're going to go into mechanics soon, but why care about VoltServer?
Well, VoltServer has been, this isn't new. This isn't brand new. Fault managed power isn't brand new. It's something that, VoltServer has been doing for almost a decade now. And, it is definitely something that is driving, this new technology forward. And the way that digital electricity, works, well, we'll get into that in a minute, but, it is something that has been, we've been developing and working on, for quite some time. So not brand new.
Okay, so tell us, just to give us a bit of coordinates, tell us where you've deployed digital electricity.
Yeah, so we have done hundreds and hundreds of different venues, over the course of time, and there's tens of thousands of loads connected out there right now with digital electricity. A few of the venues that are more prevalent or more well known, Hard Rock Stadium in Miami was a wireless densification project that we worked on. With a significant install, it required a good amount of resources and time. It was a really good marquee project that we worked on. And another one, which is much more of a smart building type of an application, is out in Las Vegas for the Circa Hotel, and that was a great project to work on, where we were able to, put digital electricity into that venue, to power PoE switches that handled lighting and room access and all, a lot of different services that were needed at a hotel. So that was another great opportunity or a great venue that we worked on. Okay,
so let's dig into it. So in order to understand what it is, the best way I found for me to understand it, when we at DES, we partnered with VoltServer about 2.5 years ago, is to understand what problem does digital electricity solve? What is the inherent problem with electricity that that class 4 power actually solves? And for me, the best way for me to understand it was to understand the laws of scarcity and to make it a little trite. Sorry, one moment. Okay, so a little trite. So laws of scarcity. I think anybody who has house and kids knows that you can only pick two things when it comes to either your sanity or kids, and you have a terrible, messy house, or you have your kids in your home, but you lose your sanity. So when it comes to scarcity, electricity does follow somewhat the same pattern. We have class 1 power, where you can only pick two. Only pick two. Either you got either you got the significant power capacity, high voltage, or you can go the long distance, or you can have safety. And then you've got class 1 and class 2 power, and they kind of differentiate in that. So Rodger, if you could just talk a bit about what is class 1 power and the scarcity or the limitations, class 2 power, and then class 4 power, and how that brings it all together.
Sure. Well, class 1 power has been the staple, and we've all been familiar and used that forever. You can transfer large amounts of power. Long distances. Of course, long distances require larger cabling, but the safety portion of it is not. It's not inherently safe. So that's the reason why there's conduit. That's the reason why there's having to have specialized contractors, specialized people to be able to touch this. And be able to get around it. So that's the safety mechanism. It has to keep it tugged away from everybody. Class 2 power, it has the inherent safety. You have the wiring standards of the NEC 725, so that wires and lays in cable raceways, and that sort of a deployment perspective However, the power is very, very limited as far as how much power capability, and the distances cannot go as far. That's why I would like to say that, digital electricity, it combines the best of both worlds. You're able to move larger amounts of power over longer distances. And you can do that in a way that's inherently safe. With the fault managed power system itself, the fault management is really what provides the safety. So that way, that in most cases, that power can be run, again, those long distances with skinny conductor cables in a way that's safe, that doesn't require that conduit or that type of specialized, electrical work. These can be, installed by telco technicians, and it can be run just like data, and it actually can be run in the same pathways as data.
Cool. Now, I'm just saying, I see your video kind of froze. I'm not sure if you can adjust that. If not, we'll just continue on. We hear you fine. So, so going back to that idea, the problem, what problem does digital electricity solve? If you did not have class 4 power, what can you not do? What actual practical difference does it make? If I wanted to get electricity over a significant distance, could I use? Is that a solution?
Well, yeah, absolutely, and that's kind of really where the value proposition comes into play. And if we're talking about applications where, especially in if you have an industrial application or you have like an extended campus application, and the problem is I need to get an industrial switch, or I need to get some kind of a device that's out in the network, that's further out. And I need to get power to that location, and that's kind of the big question: is can I easily get power to a particular location, or do I need to go through and trench and do all the traditional ways of being able to get power to that location? So that is the real question of typically whenever I need to get a piece of equipment out into the field or into the network, it's almost going to be guaranteed the power doesn't exist there today. So it is a matter of how do I get power there the most efficient and in the easiest way possible. And that's really where fault management power comes in.
Okay. All right. So let's dig into some technical details. So how does it actually work? So we have a little diagram here, and talk us through this. Tell us what is it? What's going on here? Yeah.
So, a digital electricity system, basically, it's a bookend system. At the head end or the transmitter location, we're accepting, conventional electricity. So AC power or DC power that comes in. The digital electricity transmitter shelf itself is what converts that standard electricity, that standard power, into our digital electricity signal. And at that particular point, then it's launched on digital electricity cable that can be transmitted out to a receiver. So, and there's multiple types of cables that are available for that application. It can easily be used. It can be a hybrid cable, which has fiber and copper combined all in the same jacket. And it can also be copper cable itself that can be transmitted, depending on what's easiest for the installation. And once we reach that digital electricity receiver, then it's converted back into analog electricity again, and it's fed, and that's what it's fed to the local loads. So local piece of equipment that would be there. Let's say that might be a PoE switch, it might be a high power radio, it might be another device that just requires, standard analog electricity. So that's really the schematic of how that system works. And because of the technology, the way that it works, we're able to transmit large amounts of power, so up to 2 kilowatts of power from a point A to point Z.
And 2 kilowatt can power what type of applications?
There are a lot of different applications and a lot of different pieces of equipment that can be powered with 2 kilowatts. A majority of wireless radios, 5G access point, all kind of different applications that can be used for that. What we're finding with our digital edge solution is that PoE switches seem to are well within that type of power load profile. So the power for the switch itself plus the power for all the PoE loads combined together represent a larger power profile, and that's something that we're seeing much more of as we continue on down the path. The requirements for power for the pieces of equipment that we're looking at don't get any smaller. They're getting much larger as time goes by.
Right.
So, that's something that, by having the kind of payload capacity that we've got, it kind of builds in that scalability factor, future factor.
Right. And now built into that VoltServer, into that cable, you got that kind of safety, you got that data piece that's constantly monitoring whether there's a fault. That's why it's called fault managed power.
Yeah. And that's part of the digital electricity. It sends energy packets, and we have a safety validation packet that's part of that solution. So, that's able to provide both the energy packet and the safety packet, and we're able to manage the power system that way.
Right. So if you did not have that safety packet, then I would touch 2 kilowatt of power. Would I die?
Well, I think it depends. It wouldn't be good. We put it that way. It wouldn't be very good.
Would it be good? Okay.
But our system's able to turn power off so quickly that it really very much limits the amount of energy that's transferred through the system.
Right, and I have to say that the demo system in our building here, I did actually touch it, the live wire, and it felt like a pinprick, and I did not die.
No, that's good.
Yeah.
Good.
So, but then the magic of that is that it's essentially the equivalent of low voltage cabling while it's powering devices. So that means, as you said, you can get your low voltage contractor to put it in.
That's absolutely right, and that's really the fact that we're able to utilize those types of resources that are being put data cable in today. So, and oftentimes, because you can use the same pathway, again, even the same cable, you're really limited the amount of poles, the amount of labor, and the amount of resources required to put the infrastructure in.
Right. Yeah. So just look at those use cases, and I know you've mentioned some already. So anywhere you need power and data, you can just do one single pathway. You don't have to start doing 2 different installations. So you mentioned extended campus, intelligent buildings, stadiums. Okay, it sounds like, I know. And let's see if we can. Rodger comes back. Okay, so I know there's a major stadium here in Pittsburgh that has VoltServer in it, and it was used for the wireless densification. So the fact that there's cellular all over the building is because of this ability to push out power and data.
Absolutely.
What other use cases have we? Rugged campus.
Well, yeah, extended campus applications are definitely something, and again, it comes back down to the overall, I think, umbrella of extended enterprise, and that's where VoltServer is really making strides through the market, in developing the marketplace, for these industrial applications, and that's I think that is one of the big areas that we're seeing, especially with with industrial IoT applications being at the forefront. We're definitely seeing a lot of devices that are high density. There's a lot of devices, and we're starting to see a lot of that happen. And it's just not feasible to be able to manage the density and the latency requirements with traditional network switches that are in existing telco closets and carpeted spaces. So the far push really is kind of getting the network extended out further, and so they're extending that enterprise network out into the rugged or outdoor environments, all operating on the same network fabric. So it gives them more control, more visibility, and it's smaller switching locations that are closer to the edge of the network. So it's a deeper fiber, type of environment, and that's and we can run fiber as long as basically as far as we want. Power becomes the problem, in that particular case. So that's really the question of, how can I easily get power out to those, switch node locations that might be in work cell areas. They might be in parking lot locations where I've got 2 or 3 cameras, and I've got digital signage, and I've got 3 or 4 different applications and products that are all connected to that switch that might be in that particular spot.
Right.
So powering the switch becomes really where we come into play. Fiber is being run out to those locations now, so it's just it's a natural fit to be able to get power and the fiber all out at the same location within with the same pathway.
Right. So it's almost you've probably already answered this question. The first steps to FMPS. What would be the initial question that somebody should ask themselves am I a candidate for FMPS digital electricity?
Yeah, well, I think it really comes down to, do I have a power problem? Do I have a problem getting power to a location where I need to put this networking equipment, or I need to put these assets? And what does that look like? Is it a longer distances? Do I have, and certainly an outdoor environment? Do I have to have, let's say I'm in an industrial environment and I need to be able to get power out. Do I have to run rigid conduit out to those locations?
Mm-hmm.
How far is that distance? So, I think it's a matter of, if I need to get power to a particular location where power doesn't exist today, I think all of that alone is something that is kind of the first step to asking if, fault managed power is the right solution.
Right.
In that.
Right. Anything with power, if you need power and data, then for sure.
Right.
Lights, sensors, anything. I mean, anything that's on the network and requires that power. So let's conclude with some resources and recommendations. This is VoltServer. There's your logo. Pioneering leader in fault managed power systems, or VoltServer.com. And go there, you can get everything you need to know. You can also come to us at DES. And any final point you want to share with us, Rodger?
Well, I appreciate the opportunity to discuss the information. I certainly appreciate the information that you guys have given. I think that one of the things that we want to look out for, from VoltServer, is definitely the digital ed solutions that we're marketing and putting out there. So keep an eye out for that, and please go to the website and look at what we have there. There's a lot of great information, wonderful training sessions, wonderful training packages that we've got there. So a lot of resources and a lot to be able to use there.
Okay, thank you very much, and wishing everybody a good weekend.
All right, thank you.